Pluto made them come all around. Pluto's circle cross is that of one more planet. Pluto, the baffling little planet at the outside levels of our system, via planetary rap, it is stirring up force in the domain of space science. Propelling reports show an expected involvement with Neptune, raising concerns among well-informed authorities and space fans. Clear figures like Neil deGrasse Tyson and Michio Kaku have sounded alarms about the repercussions of this grandiose event. Yet how did Pluto end up on a serious collision course with its neighboring planet? Besides, how might this incredible event affect life on Earth? Join us as we unravel how something immense just banged into Neptune and how scientists have been left fretful by this giant anomaly. Pluto, once hailed as an irrefutable planet, went through a change of its status, being renamed as a dwarf planet due to its unique orbit. Nevertheless, this minimization, Pluto still charms and fascinates the boundless community. Later speculations from respected analysts like Neil deGrasse Tyson and Michio Kaku have raised concerns about Pluto's orbit possibly meeting with Neptune, suggesting a looming series of encounters between the two celestial bodies, which could have critical repercussions for Earth. Pluto's journey around the Sun stands out due to its exceptional qualities within our planetary system. Its orbit is strangely slow, crossing an amazing distance. Since its discovery in 1930, Pluto still has not completed a round trip around the Sun, adding to its persona. The particularly elongated shape of its orbit is a departure from the more circular orbits followed by the major planets. Other than Pluto, its orbit floats off by 17 degrees from the ecliptic plane, giving its path a more inclined tilt compared to other planets. The combination of Pluto's eccentricity and its tilted orbit introduces layers of unpredictability to its orbital pattern. One excellent aspect of this is its broken overlap with Neptune's orbit for about 20 years during each cycle. Pluto ventures closer to the Sun than Neptune, contrary to expectations considering their different positions in the nearby solar system. Delving further into Pluto's orbit, it's striking to note that it's not a perfect circle, but rather an elongated path, resembling an oval. This remarkable orbit results in significant variations in Pluto's distance from the Sun throughout its journey. At its closest approach, Pluto is about 30 astronomical units AU from the Sun, while at its farthest point, it reaches 49 Australian dollars, twice the distance of Neptune from the Sun. Additionally, Pluto's orbit is tilted at a crucial angle compared to the orbits of the major planets in our solar system. This inclination not only complicates its orbit, but also plays a key role in its interactions with other celestial bodies, particularly Neptune. When Pluto encounters Neptune, their gravitational interaction alters their paths over time. The complex dance between Pluto and Neptune highlights the intriguing nature of our nearby solar system. While Pluto was once seen as a solitary drifter in the outer reaches, its close encounters with Neptune emphasize the interconnectedness of celestial bodies, each applying gravitational forces that shape the orbits of others. Recently, advancements in observational technology have allowed astronomers to track Pluto's movements with remarkable precision. This has led to a deeper understanding of its orbit and its potential implications for the stability of the outer solar system. While the possibility of a direct collision between Pluto and Neptune remains low, the chance cannot be entirely dismissed, prompting observatories and studies by the astronomical community. Despite its small size and distant location, Pluto continues to draw attention and intrigue among scientists and enthusiasts alike. The question arises, why hasn't there been a collision between Pluto and Neptune? The answer lies in the gravitational forces from other planets. Astronomers began studying Pluto's orbit soon after its discovery, and its orbit perplexed them. Unlike most planets that stay near the same plane as they orbit the Sun, called the ecliptic plane, Pluto stands out with its steep tilt and oval-shaped orbit. The mystery deepened when they realized Pluto's orbit crosses Neptune's. Despite these complexities, Pluto's orbit remains stable, demonstrating the intricate mechanics of space. Understanding how three celestial bodies, Pluto, Neptune, and the Sun, move and interact gravitationally is a significant challenge. It's similar to trying to predict where they will go based on where they start and how they pull on each other. For Pluto, this challenge reveals how its orbit, Neptune's orbit, and the Sun's position all work together like a complicated feedback system. Terms like precession, libration, and the VSOP variations help scientists resolve this vast question. Understanding these factors is crucial for keeping planets in their orbits. When Pluto crosses Neptune's orbit, it's still about 90 degrees away, preventing a collision. Libration ensures that when Pluto approaches Neptune or other large planets, it stays well above their orbit, reducing the likelihood of a crash. The VSOP variations, named after researchers von Zeipel, Puriti, and others, explain why Pluto's orbit appears erratic but remains predictable over time. Despite the turmoil in space, certain patterns and laws keep things in balance. These principles stabilize Pluto's orbit, preventing crashes with Neptune or changes in its path. The potential for orbital chaos highlights how a celestial body's orbit is highly sensitive to its starting point. Even slight changes in its position or velocity can disrupt its orbit over time. Scientists use computational simulations to figure out how Pluto moves in space. These simulations use complex mathematics to demonstrate how Pluto interacts with other celestial objects like Neptune. By tweaking these simulations just a bit, space experts can see how small changes can alter Pluto's orbit. In the late 20th century, these simulations revealed something fascinating about Pluto's orbit. Despite the factors that should destabilize it, Pluto's orbit can remain stable. Even a slight change in where Pluto starts or how fast it's moving can cause significant shifts over many years. However, despite this apparent instability, Pluto's orbit remains stable for extended periods, like billions of years. This suggests that, despite Pluto seeming chaotic, its journey around the Sun follows a kind of pattern. Predicting what will happen with planets like Pluto, which have irregular orbits, is challenging. These systems are so irregular that it becomes hard to forecast long-term outcomes. Simulations help us understand possible results, but they also show us that we can't predict everything. Understanding Pluto's orbit is essential, especially when considering whether it could collide with Neptune in the future. This knowledge gives us insight into how our solar system works. Pluto's orbit teaches us that even orbits that appear unstable can stabilize due to gravity. Moreover, the dynamics of space continue to astonish us, and studying these anomalies is vital to expanding our understanding of the universe and our place within it. When we explore space, we discover that things can be bizarre. Pluto's orbit is a prime example of that oddity. Pluto's orbit is unlike those of other planets. It's more oval-shaped, meaning it's not a perfect circle. Sometimes it even comes closer to the Sun than Neptune does. This creates interesting dynamics, because while Neptune is also moving along its orbit, there's a slight chance Pluto and Neptune could crash one day. Despite its unusual orbit, Pluto manages to avoid Neptune most of the time, thanks to what many refer to as gravitational forces. Gravity is an invisible force that pulls objects toward each other. So even though Pluto and Neptune might seem to be on a collision course, their orbits are carefully coordinated, shaped by the pull of gravity. Pluto's orbit teaches us that space is full of surprises. What seems chaotic at first can be a delicate balance of forces. By studying Pluto's orbit, scientists gain insights into the complex mechanics of our solar system. This ongoing observation and analysis is crucial to deepening our knowledge of the universe and our place within it. Imagine if Pluto and Neptune collided. Such an event would send shockwaves through our understanding of the nearby solar system. While we have made progress in understanding space, the situation suggests we still have much to learn. Focusing on how large planets affect Pluto's orbit gives us vital clues about how our entire solar system functions. It shows us that where each planet is and how it moves can impact the orbits of other objects in space. Despite the complexities of space, the possibility that Pluto could one day crash into Neptune concerns astronomers. This raises a question. Why could such an impact happen, despite seeming unlikely? Neil deGrasse Tyson, a prominent astrophysicist, has some interesting thoughts about Pluto. He believes that renaming Pluto as a dwarf planet, rather than a major planet like Earth, is a progressive step. He feels that we are continuously learning new things about how objects move in space. Tyson views Pluto's unusual orbit as evidence that there is still much we don't understand. He believes that the mysteries of space are captivating, and significant events like Pluto's renaming draw people into the study of space science. Tyson wants to help people understand the cold and sometimes strange aspects of how space works. He emphasizes that studying space mechanics can leave us awestruck. Tyson collaborates with other scientists to warn people about the potential dangers of Pluto's erratic orbit. After focusing on Pluto extensively, the possibility that it could collide with Neptune one day still concerns him. Tyson's perspective on Pluto's orbit underscores the importance of studying these unusual phenomena, as they can provide crucial insights into the larger workings of the universe. His warnings about the potential impact of Pluto's erratic orbit are not meant to cause panic, but to encourage a deeper understanding of space's complexities. As we continue to explore the outer reaches of our solar system, the mysteries surrounding planets like Pluto remind us of how much we have yet to learn. Space is full of uncertainties, and Pluto's orbit serves as a prime example of how the seemingly unpredictable can follow patterns that defy our initial expectations. While a collision between Pluto and Neptune may seem improbable today, the fact that their orbits interact in such a way is a testament to the delicate balance of forces at play in our solar system. The gravitational dance between celestial bodies, from distant dwarf planets to the mighty giants like Neptune, highlights how interconnected the universe truly is. The ongoing study of Pluto and Neptune's interactions is crucial, not just for understanding the dynamics of our solar system, but for advancing our knowledge of planetary mechanics. Even small changes in the positions or speeds of objects in space can have far-reaching consequences, and by carefully tracking these movements, scientists can predict future events with increasing accuracy. This ability to foresee and model cosmic interactions is vital for not only understanding our place in the universe, but for anticipating potential risks that could arise from the unpredictable nature of space. As technology advances and our understanding of gravitational forces deepens, the possibilities for what we might discover next become even more exciting. Every new piece of data brings us closer to unraveling the mysteries of the cosmos, and Pluto's strange orbit is one of the many fascinating puzzles that continue to challenge astronomers. Whether or not Pluto and Neptune will ever collide is still uncertain, but the scientific journey to understand their movements will undoubtedly yield valuable knowledge that can expand our understanding of the forces that shape not only our solar system, but the broader universe as well. Ultimately, the study of Pluto and its relationship with Neptune reminds us of the vastness and complexity of space. What might seem like a far-off, insignificant event, a distant dwarf planet's orbit crossing paths with a gas giant, can have profound implications for how we understand the cosmos. It encourages us to ask questions, to explore the unknown, and to recognize that even the smallest bodies in space play a crucial role in the grand cosmic tapestry.